Hi everyone. In this lecture we are going to go over the preparation of amines, and we're going to go over some mechanisms or reactions that we've already gone over in the past, and then we'll go on to new reactions. So let's start by reviewing some previous reactions that we've learned. So we could, for instance, start with an alkyl halide and then turn that into a nitrile. And from there, we could then turn that into an amine. We could also potentially start with a carboxylic acid and convert that into an amide. And then finally, reduce that into an amine. We could also start with benzene. We could nitrate the benzene ring. And then we can reduce the nitro group and form aniline. So what I would like you to do is just take a second, pause the video, and see if you can fill in the reagents for all of these different transformations. And then when you're done, we'll go over them together. Okay, let's go over the first set of reactions there. So in our first step, we're converting an alkyl halide into a nitrile. How would we do that? Well, we could just simply use sodium cyanide. So the cyanide ion is negatively charged, and it will perform a substitution reaction that will then give us that nitrile. Then we can take that a step further and convert the nitrile into a primary amine. So what reagents would we use to convert the nitrile into a primary amine? Well, we can use a reducing agent like lithium aluminum hydride, and we would need to use excess of that, and we'd follow that with water. Okay, so now let's look at our next reaction here. In the first step, we're converting a carboxylic acid to an amide. And how would we do that? What reagent would we need to use, or reagents? Well, we can first convert the carboxylic acid into an acid chloride using thionyl chloride, and then we can follow that with ammonia, but we would need excess ammonia. Now that we have the amide, how do we turn that into a primary amine? Same as above, we're going to use our reducing agent, lithium aluminum hydride, followed by water. Okay, now down below we have benzene, and we're nitrating that in the first step. How do we nitrate a benzene ring? We use nitric acid followed by sulfuric acid, or mixed with sulfuric acid, I should say. And then if we want to reduce the nitrate group into an amino group, which reagent do we use? Well, there's a couple options. You could use zinc and hydrochloric acid or iron and hydrochloric acid. I'm just going to write zinc. Okay, so now let's look at another way to prepare amines, and this is called the alkylation of ammonia. So we're really preparing a substituted amine by adding alkyl groups to it. So what we're going to do is start with ammonia, and then we're going to add methyl iodide. So ammonia is going to attack that methyl group in our alkyl halide, and iodide is going to leave. So now we've added a methyl group to nitrogen, but we still have those 3 hydrogens attached. So in the next step, we still have ammonia hanging around because most likely we have multiple copies of ammonia in solution. So this is going to deprotonate our substituted amine. So now electrons will be left on nitrogen. Now, this intermediate is hard to isolate. And what would we call this amine? Is it primary, secondary, or tertiary? Primary, right? It only has 1 alkyl group. So unfortunately, this reaction we're performing isn't great for preparing primary amines. This would keep reacting actually, and we would end up forming, after a couple more steps with methyl iodide, we would end up forming a quaternary ammonium salt. So that nitrogen atom would then be bonded to 4 methyl groups after we do this reaction. So this is called exhaustive alkylation. Now, if you are trying to make that primary amine, there is a way that you can do it. And this is called Azide Synthesis. So we'll start with an alkyl halide, and we're going to react this with something called sodium azide. And I'll draw the azide part. It's basically 3 nitrogens that are all double bonded to each other there in a row. And the nitrogen atoms on either end are negatively charged, and the nitrogen in the middle is positively charged. So we can abbreviate this as NaN3. So that would be the molecular formula, or the ionic formula. And again, this is called sodium azide. Now, in this step, the azide ion is going to attack the partially positive carbon on our alkyl halide. We're then going to release the halogen there. All right, so now the nitrogen that attacked our alkyl halide is neutral because it's formed a 3rd bond there. The middle nitrogen is still positively charged, and the other nitrogen on the end is still negatively charged. And then we've also formed an ionic compound with our halogen there. Now, there's 2 different ways that we can go here. We could either reduce this azide here using hydrogen and palladium mixed with carbon or platinum. You know, you can use any catalyst really there that works with the reduction. And this will give us, a primary amine, which is what we wanted. So it basically just adds hydrogen so that we end up with that primary amine, but notice we're still missing 2 nitrogen atoms, looking at our molecule up above. So that's actually going to be released as nitrogen gas. Now, a different way that we could end up with a primary amine here is to use a strong reducing agent like lithium aluminum hydride. Oh, and actually that's all we're using. So we can get rid of that number 1 there. Oh, wait, no, I apologize. We are using water there as well. All right, so then that would give us a hydrogen on our first nitrogen. So I'll just highlight that we're adding a hydrogen to that first nitrogen. And now in this next step, the negatively charged nitrogen is going to donate one of its pairs of electrons over to form a triple bond. And that's going to break the bond between the middle nitrogen and the nitrogen that's connected to our alkyl group. So then we're going to end up with a negatively charged nitrogen bonded to that alkyl group, and we're releasing nitrogen gas as well in this reaction. And then in the next step, we're using water to give us the primary amine at the end. So that negatively charged nitrogen is just grabbing onto a proton from water. Okay. Now, alkyl azides can be explosive, so we do have to be careful when using this type of reaction. Additionally, we're generating a gas, which nitrogen gas isn't necessarily bad, but if you're releasing a lot of gas at once, that can build up a lot of pressure, which could be dangerous as well. So let's just make a note. Alkyl azides are explosive and produce gas. So we just need to exercise caution. Now, there is another method that we could use to prepare a primary amine, and that is called the Gabriel synthesis. So the Gabriel synthesis prepares primary amines and its advantages are that it avoids toxic reagents like sodium azide, which is explosive and toxic. And then we also avoid generation of a gas. So in this reaction, we're going to start with something called phthalimide. And that molecule looks like the following. This might look familiar. I believe we have used this in the past. And we're just going to use potassium hydroxide to start, which will remove the proton from nitrogen. Then we're going to add an alkyl halide, and the nitrogen will attack the alkyl group. Then we're going to either use acid, which is a slow reaction, or we could speed up the process by using hydrazine. Although remember, this can also be a bit dangerous to use. So what we end up forming is either a carboxylic or two carboxylic acids on our starting material there, plus a primary amine. And this would be if we used acid. The other product we could form is the following. Plus our primary amine. And this would form if we're using hydrazine. Either way, oh, whoops, I forgot my alkyl group on the primary amine. I apologize. But either way, we end up forming that primary amine. So it just kind of depends on what you have available in the lab. Do you have acid or hydrazine? Also, hydrazine maybe isn't the safest thing to use always, so you kind of have to weigh the pros and cons of both. So let's look at the mechanism for a Gabriel synthesis. So we're going to start with phthalimide again. And like I said earlier, we're adding potassium hydroxide first, which is going to deprotonate the nitrogen on phthalimide, which I'll write out here. Don't worry, I won't test you on the name of this. And then we're going to have a negatively charged nitrogen. So now we add our alkyl halide, and the nitrogen atom will attack that partially positively charged carbon. We'll leave our halogen behind. So now we have an alkylated nitrogen. And then, like we saw earlier, there's two ways to go. We can either add acid, which is going to react twice with our amides there, because notice we have an amide on the top, and we have an amide on the bottom. So if acid interacts with both of those, then we end up forming those two carboxylic acids, right? And we've seen that in previous chapters. And we're releasing that nitrogen, which will end up protonating itself a couple of times to give us that primary amine that we want. Or we can use hydrazine, which kind of ends up taking the place of our nitrogen there. So we form a six-membered ring. And our primary amine. So whichever way you choose to go, either one will work. Of course, at the end we have this mixture of products, so we'd probably have to use some sort of separation method to isolate our primary amine. Okay, so before we go, let's do a practice problem. So let's say we're starting with this simple alkane, and we want to synthesize an amine, a primary amine. So what I would like you to do is, 1, name the reactant and product, just as extra practice, and then 2, synthesize the product, starting with that alkane. So figure out what reagents you need to use to get to the product. And there might be more than one pathway. So pause the video, try this on your own, and then we'll go over it together. Okay, so let's start by naming the starting material and the product. So looking at our simple alkane, remember that we always want to start by finding the longest carbon chain. So let's see, 1, 2, 3, 4. Okay, so that's butane. And then we have 2 methyl groups, one on carbon 2 and one on carbon 3. So that would be 2,3-dimethyl butane. Okay, let's look at the product. So in the last video, we talked about how to name amines. So we have a kind of a complex alkane here attached to our amine, or relatively complex. And we want to find the longest carbon chain again. 1, 2, 3, 4. And I'm numbering this in the wrong direction, So let's try that again, because we want our amine to be on carbon 1. So I'm going to go in the opposite direction. Okay, there we go. All right, so we again have 4 carbons. So that's butane, but I'm going to replace the E in butane with amine. So we have butanamine, and that's at position 1. And then we still have 2 methyl groups here on carbons 2 and 3, so we'll just add 2,3-dimethyl to the beginning there. Okay, so there are a couple of different ways that we can synthesize the product. The first way is to use Gabriel Synthesis, right? So we're going to start with our phthalimide, and we'll use potassium hydroxide or sodium hydroxide, either one works. And that will deprotonate our nitrogen, which can then attack our alkyl halide. So the alkyl halide that we could use looks a lot like our product, but instead of an amino group on the end, we'll put a halogen there. So we could use bromine. And then we'll follow that with acid or hydrazine. Now, let's take this a step further. How could we, because we did start with 2,3-dimethyl butane, how would we turn our starting material into our alkyl halide? How do we do that? So let's show that down below. This is kind of tough, right? Maybe we should do retrosynthetic analysis. So what would we need in order to add a bromine to a less substituted carbon? Would we need to perform Markovnikov addition or anti-Markovnikov addition? So this is going way back. Anti-Markovnikov, right? And that tells us we need a double bond. So what would we use to add bromine to the less substituted carbon on our double bond? HBr and peroxides. So we could use H2O2 for instance. Okay, great. Now how do we get that double bond there? Well, we probably need a leaving group, right? So maybe we're starting with bromine in a slightly different position. So in a position where we could more easily add it. And looking at our alkyl halide and then our double bonded molecule, so our alkene, how do we get from one to the other? How do we get rid of that bromine? We want to use a base, right? But notice there's a couple different places we could form a double bond. We could form a double bond in the middle of the molecule or on the very end of the molecule. We want to make sure that we're going to form a double bond on the end of the molecule. So do we need a small base or a bulky base? A bulky base. So we could use, for instance, potassium tert butoxide or DBN or DBU. Any of those bulky bases, whichever one is your favorite. Okay, so now let's figure out how do we add bromine to that tertiary carbon there. So we're going back to our starting material, it looks like. How do we add bromine to that carbon? We just used Br2 and light, so we're going to use a radical reaction there. Okay, so hopefully this helped kind of bring back some reactions we haven't talked about in a while. But also we got to use the Gabriel synthesis in a synthesis problem. So next time we're going to talk about yet another way to prepare amines called reduction amination, and we'll look at some examples of how we can use that type of reaction. And then we'll summarize all of our different preparation techniques. So I will see you then.